Hello everyone, good morning or good afternoon depending on where you are. Welcome to our webinar. Thank you for taking the time out to join us. Today's webinar is about getting more and doing more with IP's advanced modules. I'm Ross Brackenridge. I'm the Technical Manager for IP and IC software at Lloyd's Register, and I'm going to be your host today. Just a little bit background on the theme of the webinar. So obviously most of you would know IP as a petrophysics module. That was our origins, and that is primarily still what we do. But over the years we have moved into different disciplines. Geomechanics, geophysics, reservoir engineering, geology. So I think it might surprise some of you some of the functionality that we've got that you didn't actually realise we had. We very much see IP now as a complete subsurface log data interpretation package with petrophysics at its core. So today's really about just giving you an awareness of what we've got. We won't have too much time to talk too much detail about any individual module, but at least if it raises your awareness, if there's something that interests you, let us know and we will be in touch to discuss it in more detail. So the agenda is go over some of the advanced formation evaluation modules, look at some of the ones of interest to geologists, drilling and well operation modules, some reservoir engineering and production engineering modules, and finally we'll have geomechanics and geophysics. We're not going to open the mics during the webinar. There's probably too many of you to try and manage that. What we'll do is we'll go through all the presentation, but during the presentation you'll see on the GoToWebinar panel that you should see in front of you, there's a section that says questions, and you should be able to type in questions there. So you can type in questions anytime you want throughout the presentation. When we come to the end of it, we will have a look over those questions. We'll select a few and answer them live on the air. For those questions that we don't get on to, we will be in touch with you directly to discuss them later or to answer those questions. Okay, let's get started. Okay, so let's look at some of our advanced formation evaluation modules in IP. So I'm sure most of you already use our deterministic petrophysics workflow. But you can also take your interpretation to another level. I mean, perhaps you've got very complex mineralogy, perhaps you have some missing data. You maybe want to understand the uncertainty in your analysis. So here we'll look at some of the tools that you can use to take your interpretation to that next level. So Mineral Solver is our most popular advanced module. It's our biggest selling advanced license. So a lot of you may already use this. We would recommend this if you're maybe in carbonates or some more complex formations that the deterministic workflow isn't suitable for. So it calculates the multiple mineral volumes, also outputs fluid and gas volumes, porosity, that's total and effective. And for saturations, it uses that same iterative method that our deterministic workflow uses that makes it so strong. So you can see here you build up your model, you decide which inputs you want and which minerals you want to solve for, then you choose your endpoints for your model. Now, I think what sets our module apart from other ones in the market is its interactivity. So you can actually adjust any of your endpoints or your parameters interactively. You can see on the cross plot here, you can move. This is a density acoustic cross plot. and you can move your endpoints for clay or calcite, whichever minerals you're solving for. So it's very powerful, and you can actually see the end result immediately as you interact with the parameters. You can do one single model for the entire logged interval, or you can actually make multiple models, and you could actually use a different model for different zones. So perhaps you could be logging through two completely different formations, which one model doesn't actually fit the whole interval. So you can mix the models you use. So you could actually determine which model you use by zone, or you might have a discriminator. So if a curve value exceeds a certain value, it uses one model. If it then it might use another model if it goes under that value. Or you could actually maybe use fasces. So a lot of you maybe already use the mineral solver module, but have you actually thought about using a rock typing module that you could actually feed in a fasces into the mineral solver model, and then you could have a different model for each fasces, and the module would run the multiple models depending on which fasces you were in. So as I say, a very, very popular module. So we talked about rock typing there. So one of the applications for this is to create a fasces that could be imported into your mineral solver model. We've got two options here, so it's one license, but there's two different methods for rock typing. We've got cluster analysis, which groups the data into electrofasces, and then we've also got our SOM module, so that's self-organizing maps, and this is the one you can see up here. So initially we used to have this as a 2D map, and it would group your fasces into these areas of the map. Obviously the 2D had these artificial edges, so we've actually upgraded the module to have a 3D map. So you can see all the areas of this globe, if you like, have been identified as the different fasces. Both these modules are either single well or multiple well, so you can import the data from various wells to actually determine what your fasces are. So our Monte Carlo analysis module allows you to calculate the uncertainty on your interpretation. So this would typically be done after you've done your initial interpretation, whether that's deterministic or probabilistic analysis. Then you want to know, well, how certain can you be with your results? So what you can do is enter a range of values. So for each input curve that's going into your analysis, you can give an uncertainty on that value, and also your parameters. You could give a range. If you're not entirely sure of the value a parameter should be set at, you can give it a top and bottom range. And what this module will do is take that analysis and it will run through it thousands of times. Each time it does it, it changes the input parameters slightly. So what it does is it builds up thousands of results and sees what the average result would be, and also what the range of results could be. So it's giving you a spread of possible results, and these are displayed as percentiles here. So we've actually got uncertainty in the input data, and then these percentiles on your, for example, V clay, saturation, porosity. So you can get an idea of how accurate your result could be. But a very other useful thing that it creates is this tornado plot. So what you can do for any output of the analysis, for example, we've selected the net pay here, you can see the impact that every input or parameter has on that result. So you can see here that it's actually the V-clay and saturation cutoffs that are having the biggest impact on the net pay here. So it means that some of these parameters within your analysis at the bottom here, you could spend all day trying to fine-tune them. It's not actually going to make any difference to your end result. So it's a very good way of understanding the impact that all your inputs and parameters have in your interpretation and trying to help you refine that. We also have a whole suite of curve prediction modules. So what if the input data you're using to your analysis is of poor quality? Maybe there's missing data, maybe there's some of your wells have a certain curve which is missing from another well. You can use our curve prediction tools to try and predict what the value would be in that, whether it's a gap or an entire well. So the most common application is to predict continuous data from discrete core points, or predict missing data from entire or intervals or entire wells. For example, you may have core data of porosity and permeability. You could use these modules to fill in the gaps and create continuous data from that, and also predict it from a well that maybe didn't have core data. So we actually have one curve prediction license which covers these four methods. We've got neural networks, multilinear regression, principal component, and fuzzy logic. All these methods have their strengths and weaknesses, but we allow you to try all of these. And also the input parameter set that is used for all these methods is the same. So it means you don't have to set up your parameter set for each individual one. You can do it in one method and apply the same parameter set using all the different methods, and you can compare the results to see which one is actually giving you the best results. But we've also got what we call our premium curve prediction module, which is a separate license. It's called DTA, Domain Transfer Analysis, and this is something that's exclusive to IP. It's actually been used very successfully for predicting log data such as porosity and water saturation from drilling data and mud gas data. By doing this, you can reduce logging expenditure, you can get much more from your mud log data, and it reduces operational risk and hopefully drilling time as well. What we've got on the side here is just an example of how the results from our DTA model compared with using other methods such as fuzzy logic and neural network. And in this occasion, you can see our predicted saturation here is matching much better than the other methods. So that's one application that's very good for, but it's also good for defining your porosity and saturation models in one well and applying them to target wells that you maybe don't have as much input data for. We've also started using this module for calculating permeability. So we take in wells with the core permeability, and we can create a continuous permeability curve from that, or predict permeability in a well which didn't have any core data. So that's quite a few modules there that you see you can really bring your interpretations to the next level with these advanced modules. So for those geologists among you, we have our geology bundle of modules, which contains the rock typing modules we just saw, which was the cluster analysis and self-organizing maps for determining facies. But we also have our image analysis module. So if you're not already using it, we would encourage you to at least have a trial of it. Again, this is one of our most popular advanced modules. This allows you to do a complete workflow of processing interpretation of any image log data from any service company, and also whether that's LWD data or wireline data. We've got a full database of tool templates that handles all these tool types. Remember, we're not particularly affiliated with any logging vendor, so we think we've been quite fair in giving our attention to all the logging vendor tools equally. So what can you do? You can increase the quality of that image with various correction tools. You may be correcting for logging speed, streaking, or button offsets. We can do dip picking. This can be done manually, which is interactively by clicking on the image track, or it can be done automatically, so the module can automatically pick these dips. Or what most people tend to do is something in between, which is semi-automatic. You run it through the automatic picking, and then you go through and refine it by making changes yourself. So from this we can identify bed boundaries, we can identify lithological features and fractures. Displaying the results, everyone has their own preferences about how they like to display this data, so we've got a huge range of plotting styles. We have dip polar plots, walkout plots, dip scatter plots, stereo nets, so you can choose which way you want to display your results. We also have a 3D display, so you can actually see how the bed boundaries you have chosen on the 2D map actually appear on the 3D viewer. And this is all real time. This is interactive, so as you're interacting with the log plot, you're seeing this updating on the 3D viewer. So it really helps you get a better visualization of your results. It's worth saying that image analysis is one of those things that a lot of the logging vendors provide interpretation on top of the logging service itself. And it can be very expensive to actually get that interpretation done from the service company. So this really allows you to take control of that data yourself if you wish, and do your own interpretation in-house, and you can actually save a lot of your costs from getting the service company to do it on your behalf. Okay, so now we're going to talk about the drilling and well operations bundle of modules. We've got 5 modules in this bundle. The general theme between all of these is you're basically trying to make an informed decision on your data, which can then be fed back to the well site. So let's have a look at these. Firstly, pore pressure module. So to ensure a safe drilling campaign, you really need to understand the pressures of your zones and what the mud weight should be during the drilling of each section. This module allows you to take log data and determine what that mud weight should be throughout each section. So you can do this by taking in resistivity data or sonic data, V-clay data. You could use data from an offset well, so this could be done up front to model what you think the mud weight should be in an upcoming target well. So once you've actually calculated an expected mud weight, you can also actually do this calculation real time as well. So you could be receiving data from the rig as you drill it. You could check that your estimations of mud weight are still valid. If they're not, you can obviously communicate that back to the rig that you think you maybe need to recalculate what the mud weight should be going forward. Now, I mentioned real-time analysis there, so how do you get your data from the rig Well, we have a module called XStream Connect, and this allows you to connect with the well site, and you can download the data from the well operation using a WITSML link, which is the industry standard way of connecting to a well site. So, yep, you can get live data from all the various service companies. You can update your analysis. We just spoke about the pore pressure analysis, so you could effectively have the data coming in, and maybe every 30 feet or something you could update your analysis. You could rerun the analysis and check how the results have changed. But you also might have your petrophysical analysis. You might be doing your deterministic porosity, water saturation analysis on raw data as you're actually drilling. So each time you get more data, you can actually set up the analysis to automatically update. So each time you get a bit more of your analysis coming in. And you can also do this for single well or multiple wells at the same time. So we've seen how we can stream data from the well site using XStream Connect. Now, if you are streaming wireline data, that's likely to be depth-based. But if you're dealing with logged well drilling data, LWD, it's more than likely that's going to be time-based data that's being transmitted to you. If you are working with time-based LWD data, we would suggest you use the Chronolog license. This allows you to create wells indexed to date and time, and plot data reference to date and time, rather than depth. Now, you could actually do your analysis in time-based as well. So any of your modules, PhiSW for example, you could calculate your results based against time, or you may want to convert that data into a depth-based well. If you want to do that, we have this tool called time to depth. We can look at the data, a reference curve against depth versus time, and you can decide which sections of data you want to keep and convert to time. Once you've done that, if you hit run, it will create a new well reference to depth using with the data that you've selected. Another module that can be used real time is our Geosteering module in IP. This helps you ensure you reach and maintain the desired path through the target formation. You can see here we correlate the data from the target well with an offset well, and that way we can see if we're still on track. And we can also look at the data in this curtain style plot where we can see how the well is positioned within the formation. So it uses conventional log curves, gamma ray, density, sonic and resistivity. You can also display your well position over seismic data as well. You can drape it over a seismic image. But this allows you to make sure you're still on the right track to hit your target zone, and once you're in that zone, managing to stay in it if you're drilling highly deviated or horizontal wells. And this allows you to maximize the well's potential and minimize rig downtime. So once drilling is complete and casing is put into the well, the next stage of the operation would be to cement the well. Now, we usually use cement bond logging tools to assess the quality of the cement. These cement bond logging tools have got a reputation for being quite subjective and maybe inconclusive. So we developed this cement evaluation module to allow you to take raw data from these CBL tools and very quickly step through a workflow to assess the quality of the cement. So the workflow allows you to check the quality of the data, remove hardware effects. It allows you to assess the quality of the bond from the casing to cement, and also cement to the formation. It makes sure you have good coverage all the way around the borehole. And it also allows you then to make a clear conclusion on each interval within the data set. So here we've got a table that actually indicates, a red would indicate that it's actually failed some of the criteria we've put in place. Green is passing all criteria, so this zone would be likely to provide, there's a good chance of it providing an annular barrier. And then we have amber coloured zones which are partially passing. So from this we can actually create a report very quickly. We can export that as a spreadsheet or a Word document or a PDF, and this can be sent back directly straight back to the rig. They are usually waiting for a decision on cement quality so they can make the next operational decision of what they're going to do at the well site. So what we've got here is a way of very quickly going from raw data to a clear conclusion on the quality of the cement. And that can really save rig time and speed up operations. Okay, we'll now look at the advanced modules which overlap into reservoir engineering and production engineering. So we've got 4 modules here. Hydraulic flow units is a bit like a rock typing module, but this time we're actually determining the flow potential of each individual zone. This can be applied single well or multi-well, multi-zone. The flow units are determined from porosity and permeability, which can be imported as discrete core data or continuous log data. And these we have 3 industry standard approaches that we can use, 3 methodologies: RQI, Winland R35 and Pittman. And we have interactive adjustment of the histograms and Lorenz plots. Saturation height. So we can do our saturation versus height functions either from capillary pressure data or from the calculated water saturations from our PHI-SW. So it's a very interactive module. You can pick both free water levels. You can do IFT correction on the log plot interactively to fit your SW calculation. And once you've calculated these regression functions, you can apply them to other wells in your field to keep consistency across your wells and correlate the free water level between the wells. Formation testing. So data from formation testing tools, we can import the data and start analysing the data. You can see here we've got pressure and volume versus time, so we can do a drawdown analysis by picking our drawdown points. We can do a derivative analysis or a build-up analysis, and from these we can estimate fluid mobility and permeability. So you can actually do all this from scratch, taking in raw data, or you can import data that's already been interpreted as well. And you build up this table. So for each test, you have a final pressure, and a hydrostatic pressure. So we can then cross-plot these results, and so we have the final pressures against TVD, and you can see the different gradients there made up by the individual tests, which represent the different formation fluids, and where these intersect would be our fluid contacts. Production logging. So once the well is on production, there may be, usually it's when there's some issues with production, maybe we're producing some unwanted fluid, perhaps more water than we expected. So PLT tools are used to investigate the flow downhole. So our module can take all this raw data and calculate the exact contribution that each fluid type is having at each depth of the well. So here we see raw data coming in. We've calculated fluid holdup, fluid velocity, and ultimately the flow rates, cumulative flow rates, and the flow rate from each individual zone. So it's all done in a step-by-step workflow, which is basically pulling together lots of sub-modules. So initially this was for conventional centralized PL tools, but we have recently upgraded it with an entirely new workflow, especially designed for more advanced array production logging tools, such as the GE Maps tool or the Schlumberger FSI. So here you can see how we've got results which cover the whole cross-section of the borehole, where we can see how the hold-up and velocity changes from the top to the bottom of the well. Obviously this is for highly deviated or horizontal wells. So it's also because you're doing this within IP instead of an external third-party product, all your results are in the same database alongside your open hole results, and you can also use the results from this to influence your open hole analysis or vice versa. So a little bit more on that. I think we could actually look at these modules, well, they are individual modules. We should really look at them as being modules that could feed results into each other. For example, hydraulic flow units, we could start with some core data, calculate our flow units. We could use one of the predictive tools to then make continuous data from that discrete data. That data can then be used to create our saturation height functions. Then once we've actually calculated our production logging data, we can actually see, well, did our well actually produce what we expected from the individual zones based on the analysis we'd done from the open hole data? If it didn't, perhaps those results can influence your volumetric interpretation, so you could refine that. That could then go back into your hydraulic flow units. So all these modules can feed each other, and each time they do, you're refining the analysis of each one and learning from the results of each one as well. So it's quite a powerful group of modules. Okay, now let's look at our geomechanics suite of modules. So these modules can be used and licensed individually, or they can be used within the Geomechanics Workflow here, which easily steps you through the full workflow. First of all, it starts with calculating rock strength and rock stresses using industry standard methods for determining stress components. Some examples there. It then goes on to the Pore Pressure module. This is a module we've already seen in the drilling section. So this is where we're actually trying to get a handle on the optimum mud weight to be used during the drilling of each section. So that's really looking at trying to determine overpressured zones by using compaction trend lines. Next module is Wellbore Stability. This time we're actually looking at the stress on the rock face itself. How much pressure would be required, or how much stress would be required to result in a breakout, and what would be the optimum weight of the mud column to avoid these breakouts. Again, this can be done single well or multi-well across the whole field. And finally, we have the Sandpit 3D module. So this is predicting the likelihood of sand production under various different conditions and with various different completions and perforations. So when you're planning for the likelihood of sand production, obviously there's some very expensive solutions in terms of downhole hardware, but this module lets you do an independent assessment of how likely it is you're going to need that type of completion. Obviously, when we're producing the well, the easy way of increasing production is to increase the drawdown, but how much drawdown is going to start impacting on the integrity of the well, and what's the point that you're going to start producing sand. So, as I say, this allows you to have an independent assessment, and it could save you a lot of money on expensive completions if you then conclude that the likelihood is actually quite low. So the final bundle of modules that we're going to look at is for geophysics. First up, the acoustic waveform processing module. So this allows you to take raw acoustic data from either LWD or wireline data from all the major service companies and some smaller ones. Again, we don't have an affiliation with a particular logging company, so we try and treat all the logging tools equally. We've got a very comprehensive library of tool types. So we allow you to do semblance processing on this data, which means you can calculate a new compressional and shear curve from your data. We can handle data from all the different tool modes: monopole, dipole, quadrupole, cross dipole. We can calculate anisotropy, dispersion assessment and correction. And it's a very easy to use module, very interactive as well. You can change your correlation window parameters and frequency filters and immediately see what sort of impact that's going to have on your results. Again, this is one of these modules that often the logging vendor will provide interpretation on top of the cost of the logging itself. It can be very expensive. I used to do this type of interpretation for a service company myself, and I know what it can cost clients to get that done. So this module really empowers operators really to be able to take that work in-house, and in doing so save quite a lot of revenue from doing that. Curve prediction is the set of modules. We've already seen these earlier in the presentation. The reason they're part of the geophysics bundle is because it's essential that we have good quality acoustic and density data as input to the rock physics module that we're about to look at. So it's a very useful tool as a pre-step to the rock physics. So here is the rock physics. I would call it a workflow really than a particular module. And these are all sub-modules within that workflow. Ultimately, what we're trying to do here is take log data and convert it into a format that's compatible with seismic data. So we're taking density and sonic log data. We can calculate an acoustics impedance and Poisson's ratio from that data. From that, then we can create synthetic seismograms and also calculate elastic impedance. So ultimately we have the data in a format that we could compare to our seismic data. And the fluid substitution also allows us to see what these intervals would be like, whether they were hydrocarbon filled or water filled. And that allows us to look at seismic data from other areas of the field, and we might be able to recognise what may be a hydrocarbon filled zone or a water filled zone.